how's everyone enjoying the first NDC in the States? It's pretty good fun. I've had a good time. I only managed to make a couple of talks. I saw the Progressive Web App by Nick Molnar yesterday. A lot of that code would have been made great by TypeScript. Also, Dave Neal's was an awesome talk on leadership. Yeah, it sounds like there's been really good reviews. So I'm here to talk to you about TypeScript. I've done a couple of talks on TypeScript. This one, I really want to focus on what's been going on after TypeScript 2 got released. So quite a lot of people have talked to me and said, oh, TypeScript has these problems. TypeScript is evolving so quickly. And the things that I've noticed over the last couple of years is, hopefully that'll come back. Sorry if it keeps doing that. If you're coming from sort of a JavaScript background, going into TypeScript was a little bit annoying. If you're coming from sort of a .NET background, a lot of the patterns that you could originally do were fine. So a lot of the features that I'm going to be focusing on through the second half of the talk are all kind of the features that allow you to be really expressive with TypeScript to sort of match the latest patterns that are available. My name's Jake Ginnivan. I'm from Perth in Western Australia, so it's a fair way to come. It's been a pretty good trip so far. I work for a company called 7 West Media, and specifically it is an umbrella, and there's 3 main companies that are under it. West Australian News, who I work for, Channel 7, who is the biggest TV station in Australia, and Pacific Magazines, which promote and write a lot of magazines. So the West Australian's actually quite an old company. We printed our first paper in 1833, so from an Australian standpoint, it's really quite an old company. We didn't start out using TypeScript. Our team is actually quite young. About 2 years ago, all of our website was outsourced. Yahoo was actually hosting our news site. And we decided that as a company, we'll take control of our digital strategy because at the end of the day, printing the news on dead trees is only going to take us so far. So what our stack looks like is we're using React, server-side rendered, putting it all together with Webpack, Node on the back end. So we're JavaScript everywhere. We started out with Babel and ES6, and we converted to TypeScript after we launched. The choice to not use TypeScript straight away was an interesting one because coming from a .NET background, moving across to everything's written in JavaScript was pretty interesting for me. But at the time, Webpack, the loaders around it, were just pretty immature. Before TypeScript 1.8, there was really pretty poor support for Node.js's module system, CommonJS. Can I just get a bit of an idea? Who's sort of a JavaScript using NPM, Node, that side of things? What about .NET? Cool. What I was guessing. So the Node community has a package manager similar to NuGet called NPM. And predominantly in the JavaScript space, there's 2 competing module systems. AMD, which things like the package manager Bower uses, and Require.js kind of as a module loader for that. And then you have the Node side, which tools like Browserify and Webpack allow you to use the Node module system on your front-end client websites. And yeah, before TypeScript 1.8, not very good support. So if you're using Bower, everything's global, you had a pretty good time. If you're trying to use new module systems, not so much. We wanted to use, because we're React and Redux, you commonly want to take advantage of patterns like REST and spread in your reducers. Those language features were not available, nor was JSX. So those were kind of showstoppers, and we launched the website 4 months later. It was a pretty short build, and so we were under pretty big, like a lot of pressure to deliver, and we got it out there. JavaScript, great for getting stuff done, but later on, we moved across to TypeScript for a number of reasons. Oh yeah, and also just what I was talking about, if you're coming from a .NET background, easier, but if you're coming from the JavaScript land, there's a lot of idioms and sort of patterns that the JavaScript community use, which you just couldn't express in TypeScript because the type system was not powerful enough. It's pretty interesting when we dive into sort of what the TypeScript brings to the table. A couple of things I want to cover. What it is, I'll go into that a little bit of detail, and why it will actually help you. Also, introduction, what it is. Who here has used TypeScript? Quite a few, awesome. We'll go through that bit quickly then, but for those that haven't, it'll be important. And then finally, get into the features, which is probably what you're all interested in. So what is TypeScript? It's a superset of JavaScript that adds a static type system on top of JavaScript. So JavaScript is a pretty loose language. It's object-orientated, so functions are objects, but there's only really a couple of primitives. You've got numbers, strings, objects, and not much else. What TypeScript does is allows you to add an entire layer on top of JavaScript, giving information about the shape of these objects, what you can do with them, if they're null, all of these sort of things that you want to express. So if you're using, say, React, there's all of these helpers, so you can define prop types, but they're all runtime errors. What we want to do is move all of those errors to compile time, so we can actually make our lives a lot easier. The interesting thing about TypeScript is, unlike other languages, they made a conscious decision that they would support JavaScript as a base level. So you could start out with JavaScript, and that's valid TypeScript. And then you can just slowly add more type information over time to sort of get the benefits of it. The other interesting thing that trips a lot of people up when you first start is TypeScript essentially removes itself when it compiles. So in .NET space, we're used to runtime type checking and being able to interrogate types at runtime. We can't do that in TypeScript. We can only write JavaScript that gets checked at compilation stage. So having to separate that in your mind can be a little bit difficult to start with. So for me, there's a number of reasons you want to get started with TypeScript. There was a conference a while ago called NextLang in 2012, I think it was, and they had a panel of people who are experts in languages. So there was Eric Meyer, Anders Hellsberg, and a couple of others. And Anders and Eric were talking, and Eric asked him, so are you saying that you can't actually write large programs in JavaScript? And Anders responds, no, you can write large programs in JavaScript, you just can't maintain them. And so Anders has a lot of language experience. He's the guy behind C#, Delphi, and TypeScript. So his experience around this was, there's a team at Microsoft that built the editor behind VS Code. It's called Monaco. When they got to sort of around 200,000 lines of code, they were just really struggling to continue adding features. They were only spending about 5% of their time writing new features. The rest of it was just reading code and fixing issues, which then often introduced new issues. So they just found they were slowing down over time. So they adopted TypeScript gradually to help them actually start moving at pace again and spend more of their time implementing features. If you're interested, that panel's quite interesting. There's a guy that talks a lot about database languages and a few others. But there was a couple of problems that TypeScript's trying to solve. First one is down-level compilation. So you are writing in ES 2016, 17, 18, 19, all these new language features, but we're going to have to support IE 11 for ages, and that'll only run ES5. So the first job is bridging that gap, allowing us to write new language features, but compile down. Second one is type checking. Remove all of those runtime errors, move them all to compilation failures. And then improve development speed by types mean the development tools have a lot more context, so they can help you out, give you a lot of useful features. So they're kind of the main problems that TypeScript was trying to solve. The first one I'll just touch on a little bit. It's a little bit small, but you've got the different versions of JavaScript. That's the current state of the web. We have the state of server JavaScript, depending on what version of Node, and then that's what we want to use. So our gap that it's bridging is between one of those. The more interesting one is the next two. So I'm going to give you a little bit of a run through of what TypeScript gives you. There we go, there we go. So working for a newspaper, whoa. Let's see if we can fix that. Doesn't like virtual desktops, clearly. It'll come back. There you go. Cool. Good. Can everyone read that up the back? Sweet. Okay, so working for a newspaper, we write articles. We've got a type that is something like this. It's got a heading and a bunch of other things, and then we've got the individual content blocks that can have different types. So we have a stand first, which is kind of the first important paragraph, some text, a block quote, and also some text with some formatting in it. So quickly, going to just write some types around this. So the way we describe shapes in TypeScript is with interfaces. So I have an interface and call it an article. I can then define what the keys are on that. So I've got a heading, and it's of type string. So we're telling TypeScript what values are valid for that particular key. I can then say contents, and I'm going to say it is it's all of the values have to be blocks. So this is where the IntelliSense and the tooling comes in. I've got a type that exists in another module. TypeScript knows about all of the types in my project, so I can actually just import this from that module, and TypeScript will add the reference. Being from .NET, this seems pretty trivial, but it is a lifesaver when you've got a really big project and you're actually working around JavaScript. So that is our basic interface. Another thing about major difference between, say, C# and TypeScript, TypeScript is what's called as a structurally typed language. And what that means is if I have another interface called article2 that looks exactly the same, I can actually assign those variables to each other. So as long as when you're doing variable like assignments, as long as what you're assigning has everything and meets that contract, it can be assigned. So that's also known as duck typing. But TypeScript's a structurally typed language. We're using React. I wouldn't worry so much not going into React, but we just have a simple function here that takes a number of properties and then returns some markup. So this is a similar pattern in Vue, Angular kind of, not really, but we can continue. So it's a function. I want to type this function. First thing I want to do is declare an interface, which is the props, like that first argument of the function. So it's just article, component, props. It has one property on it, which is article, and it is of type article. I can then start typing my function by saying this is an article component props. Pretty easy. It's picked up an error, which is I don't have a property called content, and that's because it's actually contents. It's guessed that that's probably what I mean. Quick fixes. This is the tooling thing coming in. Pretty handy. But this is not as far as we want to take it. So there's a feature that is going to be built on in the rest of this talk called generics. Who's familiar with what generics are and how they work? Cool, got a bit of an understanding. So I'm going to make this a generic type. TypeScript allows you to define not only interfaces, but type aliases. So I'm going to call this a render function. And the render function has some props, and it returns a JSX.element. I now want to type props, but I want this render function to work with any component. So I can introduce a generic type here. And all a generic type is an argument to that type. Same as functions have different parameters, generic types are arguments for a type. So I can now reference that type anywhere in my type definition. You could also do the same thing with interfaces. You could make that generic, and then I could say options is a T sort of thing. Does that make sense to everyone? Got what generics are? It's going to be built on a lot, so if anyone's got any questions, just throw your hand up, we'll answer them as we go. So now I can make this a render of article component props, and I can get rid of my type definition there. And they're really the basic building blocks of TypeScript. We've kind of seen that we've got a number of primitives. We can define types pretty easily, and I didn't have to rewrite my code. I just added extra syntax. So that's kind of the goal. Any questions around that? Yes? Yeah, so for those that don't know what JSX is, JSX allows us to write basically HTML inside our JavaScript. And what happens behind the scenes is the compiler just turns it into a function call. So if you're using React, it'll turn it into a React.create element of type div. If you're using Vue or another thing, it might change it into an H function. But that's all JSX is. So when I use JSX, those function calls return a type, which is JSX.element. So JSX is a namespace in TypeScript, and element is an interface inside that namespace. That answer the question? No, so it isn't. Yes, so the question is, what is the type here? It is article component is a variable that is a function. So this is our assignment operator, and this is our function, the JavaScript, and the type is render, which is a function that returns JSX. It is a function, exactly. And the way we declare a function is the lambda arrow function syntax. So not using the function keyword, but I could write this as, make it a little bit clearer. So I'm assigning a function to that particular variable. Make sense?
This syntax doesn't tell you what.
If I hover over here, it will tell me that that is a function. So render of article component props is an alias of like the actual function. So you can compose types together and simplify them by using type aliases. Make sense? Awesome. Any other questions? Cool, jump on. So, intro to TypeScript. Gone over a few of the basics. I really want to get into modern TypeScript and kind of what's come after 2.0, because the language just keeps going from strength to strength. Even when we started with around TypeScript 1.9, we had a few things that we had to make extra complicated because the language wouldn't allow us to express what we wanted. So the first amazing feature that came with TypeScript 2.0, this was kind of the game changer that has allowed every other new feature to come out. And it's something called control flow analysis. So what control flow analysis allows us to do is we have a function, a type alias called getLogMessage, which is a function that returns a string. right? So get log message, function returns a string. We're then declaring a log function. So this allows us to write to the console. And it takes something called a union type. It's got one parameter called message, and it has a union type, which is string or the get log message function. So it can be either of those. So it's pretty common in JavaScript. You can pass like a string or an options object or something like that. We can then write JavaScript to check the runtime type of that type. So if type of message is a function, we know it's a function. Inside that block, I can call the function and pass that to console log. What is the type of the message variable on this line? Anyone? Sorry? String. It is at runtime. So before, this is where control flow analysis is really cool. Before TypeScript 2.0, TypeScript would think the type is string or get log message. We know it's not because the function returned inside the if block. There's no way I can get to that line and it's still a function. But TypeScript type guards, which is what we've got in there, checking if it's a function, they only worked within the block. I could fix this by adding an else keyword and putting that in the else block, but that's really not idiomatic JavaScript. So after it, as soon as we return, TypeScript will remove the union with that function type from it. Narrows the type down, so it's only a string for the rest of that function. It's kind of an important building block. Does that make sense to everyone? Excellent. So that allows you to write code that just works. It's amazing how much more intuitive this makes life because you don't have to keep fighting the type system. The next feature I want to talk about is kind of inspired from this quote. Software developer Tony Hoare had, in 1965, invented the null reference because it was easy to do. He calls it a billion-dollar mistake, and it's led to a heap of crashes, bugs, and just issues over the years, and he reckons it's caused about $1 billion worth of damage. In JavaScript, you could say we have a $2 billion mistake because they introduced both null and undefined for some reason. And this is probably the most common error, which, quite usefully, there was a tweet by Sunil Pai. This guy sort of introduced Glamour and kind of started the CSS in JS movement. But he tweeted out, what are the most common sorts of bugs? And then quoted it saying, you'll need a type system. But the biggest 710 votes, about 50% of them undefined. That was only tweeted yesterday or something, so quite timely. This is the most frustrating error because at some point a variable has become undefined or it's not defined and your program just crashes. This is a great GIF. So over the top. So what they've done is introduce a feature called strict null checks to fix this problem. It is amazing. If there's any reason for you to switch and start using TypeScript, it's this. So in TypeScript 1, all types could be undefined. So I'm declaring a variable, x, and its type is number. In TypeScript 1, I could assign undefined to a number. All types are undefined and whatever type that is. 2.0, they introduced this strict null check flag. So it's a flag, a config variable that you turn on in the compiler. What that does is it removes undefined from all types. So they're just the type. They introduced a new feature as well called unary types. So unary type is a type that can only have one value. So the type of null can only have the value null. Same with undefined. There's a few other unary types that you can now introduce, pretty useful. We'll go into that a bit later. So now, if I try and declare or assign undefined to number, or that variable doesn't have an assignment within the scope, like the compiler can't see that it could be undefined, you'll get an error. So now if we want to do it, we can use union types and say X is now a number or undefined. And that's how we can introduce nulls and undefineds back into our code, but we're in control of what can be. Similar idea to optionals or nullable types in .NET. But it works for interfaces as well. So how does that work? Well, using that and control flow analysis, we have a logger here with an options object. The question mark there makes it an optional function, parameter rather, and it is of type an object with one key, pretty, which is optional, and that's of type bool. So because it's optional, it's or undefined. Oh, wrong thing. And this is where like really weird JavaScript idioms and short syntax around like not options and the second statement will only evaluate if the first one is true. And for some reason, JavaScript developers love doing stuff like this because it's completely unreadable. And but anyway, before it wouldn't matter. If we did this, TypeScript would still go, options is possibly undefined. So here, you wouldn't know if pretty, like if you could access pretty safely. But now, with it turned on, if I comment out line 2, TypeScript will give me an error saying options might be undefined and won't compile. Comment that, uncomment it, it knows that I cannot get to line 3 without options being defined. I then do the same thing for the pretty value, and I'm safe to go is pretty, is a boolean, which options.pretty. At that point, it's now an object with a key that is a boolean, because type narrowing has removed the optionality and the undefineds from the parameter. So really, really handy. After doing this, I can refactor a bunch of stuff and it just works. One of the things, though, you've got to be really careful about is never lying to the TypeScript type system. So if you say a variable cannot be undefined, you better make sure that your code doesn't accidentally make it undefined. The compiler can only do, it can only work with the information you give it. So let's say you make an API call and the type says something is going to be not undefined, like it's a required value, but the API returns it's missing. You're now lying to the type system because you haven't validated that the runtime object matches what the type definition is. So anytime you're getting external data into your program, make sure that it matches the runtime, like the runtime will match the compilation time. Really big one. Next really cool feature. Anyone have any questions so far? Cool. Next feature, which is really handy, is tagged unions. So we saw the union types before that allows us to do this or this. Tagged unions allow us to take that a little bit further and write even cleaner code. So I've got a bunch of types for my blocks. I've got the text block, stand first block, and block quote. Each of them get a kind property added to it with the unary type of text, which is a string literal. So the value of kind for that interface can only be text, this string text. Before we could do string literals, I would have to say that's a string and it could accept any string. This is important because I can now do a union type as we saw before. So I've got my blocks and it's one of those three. You can also get at the type, which is a property on that type by using the array indexer. So I can actually grab the three values, and you can see the value down the bottom, and assign that to the type block types. Does that make sense? So the type block types is equal to all of the possible values of kind from that union type. Makes sense? It's quite a few steps. But what it allows us to do, and once we see this, hopefully it'll make a little bit more sense, I can switch on block.kind. So I've got a blocks variable that's come in. I can just switch on block.kind. The compiler knows that I can only have 3 potential values. Text, and then inside that case statement, I get full type safety. This is what tagged unions are doing. So because TypeScript knows that block.kind is equal to text, and those were one of the 3 union types, it can type narrow it to that is a text block, because the other 2, the kind property, has a different value. Does that make sense? So block.kind equals text, TypeScript knows that, so inside that block, it narrows it down. So I get full type safety around formatting. Inside the block quote, quote and cite are also available through IntelliSense. But for instance, inside the block quote block here, if I tried to access .text or formatting, I'd get a compilation error because it knows the type, makes sure that we can't access things that aren't there. Does that make sense? Yeah. I'm not. So I was just showing, yeah, so good question. On line 17, I defined a type alias called block types, and I'm not using that anywhere. That's correct. I just put that in to sort of show that we can access the 3 different kinds of blocks. Just kind of. Totally. Yeah. Exactly. Yeah. It's just an extra bit of context. Finally, you can do exhaustive checks. So TypeScript has another special type called never, right? And never, as soon as the compiler sees that it can get a never type in execution, it won't compile. So what this is doing is it's returning never, and that means this method will never return because it throws. So if I add another block type and I'm missing the case statement, TypeScript will be able to get to that default case because it's been added. So then it'll fail to compile saying, say I added something like a, I don't know, a video player or an image or something like that. As soon as I added that, I would have an error saying image can't be assigned to never or something similar to that. Really handy. I said earlier that TypeScript is a structurally typed language. This is kind of the closest thing that gives us nominal types. It's not quite, and nominal types are the ones that even if all the properties match, they can't be tied, like assigned to each other, because say you've got a flight and a car trip and they've got the same properties on it, a flight isn't a car trip. In .NET, you can't assign them. In TypeScript, you can. But this just means when you have lists of different things, like these block types, way, way nicer. Any follow-up questions from that? Cool. Next one is indexed and mapped types. So these came a lot later, like 2.4, 2.5. Really handy type. So the scenario I'm going to use is feature toggling, and this is something we have. In fact, we actually use LaunchDarkly as our feature toggling service. So I can define a feature, has 2 properties on it, enabled and can the user toggle it? Because I've got you can go to a toggle page and users can actually turn on experimental features when we want to allow them to do that. What indexed features allow us to do is say, I don't care what the keys are on that object, but all values on any key must be the same. So feature name is a string. So the key is a string, but the value must be a feature. What does that actually look like? I can define my features as an object, which have two keys, autoplay video, name of the feature, or new article page. Once again, name of the feature. So the first one is just a feature toggle. I don't want to expose that to the user, so can user toggle as false, but it's turned on. Love when players do that, super annoying. But I also want to expose our new article page to users. So if they go to like /features, they can switch that on. But I don't want it turned on by default. We're just starting to play with it. So I can add any key, but the value must conform to my interface. This is map types, index types, sorry. An extension to mapped index types is mapped types. So here I've got a union, which is autoplay video or article, new article page. These are my two features. Instead of making the key type string, I can say all the keys in the features union are the keys with the value of feature. What does that actually look like? Oh. So if you look down here, the type feature state is actually the same as what we had before, except I'm enforcing it. So if I add another feature to my features union, this line will fail to compile, saying you need to define key, whatever that feature is. You can also get the keys of any type using the key of function. So I can go feature in key of feature state and then put that in feature description. So this allows you to, you've got an object with a bunch of keys and you want to transform the type of all of the values. You can do that with map types. While these are sometimes a little bit complicated, these features, you've got to remember where TypeScript is coming from and what it's trying to do. So the goal of TypeScript is to allow us to type the JavaScript ecosystem. One of the things that we need then is if we pull down Lodash or React or any module on NPM, it's just JavaScript. It's missing all of these types. And there is a huge ecosystem out there with all of these different libraries that have different patterns, different APIs, all these complex and different ways of doing things. These features, you might actually never use them unless you have to write a type definition for one of these NPM modules. So there's a repository called Definitely Typed, and it contains type definitions for all of these modules. So when you install a package off NPM, you can then install the type definitions off NPM as well. And then that gives TypeScript the information on how to type check that particular library. Not every library is covered, so we've probably had to implement half a dozen different libraries. So yeah, this is where these sort of features become super handy. There's a number of built-in map types. So I've got an article here, which has a heading, which is a string, an optional byline key, and the content blocks. So they have partial, make all of the properties optional. Read-only, make all of the properties read-only. Finally, you've got pick, which says pass in article, and then pass in a union type of all the keys I'm interested in. So that will create a new type, which only has heading and byline, but it'll take the value types and bring them across. This is really handy. We use these features all the time to simplify it. Often, if you ever use like object.keys, you probably are going to be using this feature to make sure the types are correct. This brings in a problem. So if we have a look at, take this a little bit further, we have a style guide or a design system for all of our React components. So we want to document all of the properties that are being passed. So anyone can just go to our style guide They get an information on all the props and the docs on it. So we do this by creating a type, which is describe, some interface, which is an object. We then have a map type, which is key in all the keys of that type. So key of T, and then map that to a string. Describe article looks something like this. It's a heading with a string, it's an optional byline, and contents. So this is problematic because when we actually use that, I don't get a compilation error. My optional field isn't documented because the optionality comes across. So we can do that one better using type modifiers. I can actually go minus question mark, and as it's doing the mapping, if any of those keys are optional, it will remove that type modifier or that key modifier. Make sense? Cool. Before that, the number of hacky workarounds to remove type modifiers was awful. There was a huge GitHub thread, and you end up trying to find it and copying these 3 interfaces which do awful things with generics to do exactly the same thing. The last big feature that I really want to talk about is conditional types. So this is something that came in 2.8. I'm going to take this a little bit further. I have my article summary, which missing a state. The top interface, it has byline, which is an object. So it's not just a flat object anymore. Previously, my documentation for this would just be heading, which is a string, and byline, which is a string, because they're the keys. I want to make it deep. So now my types can have ternaries in them. So if the value for a key on type T is an object, say that again because it's a little bit quite wordy. So it'll come back, hopefully. Timing. Sweet. So if the value, so I can access, I'm going through each key in that object type of T. I can get the type of the value by using the array indexer, and then checking to see if it's an object, and if it is, I recursively use the same type. So now I have a deep describe interface. So if it's not an object, just fall back to string. So that'll be for arrays and numbers and such. So now my article summary description will look something like this. Heading of string, byline as an object, which has 2 keys on it, and then finally contents. So that's kind of what you get there. Super handy feature. There's a bunch of applications for this. So we saw the read-only interface before. Well, that only is the top level. So if you access that, the next level down won't be read-only. Using this, we can make an entire object structure recursively read-only. So there are so many possibilities. The amount of code that I got to delete with this feature was great. Just cover what I've gone over. Control flow analysis makes JavaScript really natural, or TypeScript really natural. Types are what you know they are at runtime. You don't have to do that mapping in your head. Strict null checks, being able to turn that on, undefined is not a function, goes away. It's amazing. Tagged unions, if you have a list that have different types in it, this feature makes your life so much easier. It was awful before. Similar to like .NET 1.1 when you didn't have generics, you just had this blob of array lists and you had to try and figure things out manually. Indexed and map types, being able to transform a type of an object to another one. Type modifiers, just making it easy to remove the things that are coming across. And finally, conditional types. So there are not that many features there. They all sort of build on generics and a bunch of the other stuff, but I think in TypeScript 2.8, they had well over 10 new features just in that one release. Since TypeScript 2, the feature list is huge. Bit of a recap when it comes up. We went over what is TypeScript, why you'd be interested in it, bit of an introduction, basic features, and a whole heap of awesome stuff that's come since 2.0 got launched. That was modern TypeScript is awesome. Hopefully it gave you some insights into, if you're not using TypeScript, why you should be using it. And if you are, there's been so much released since 1.0 and early 2.0 days. Just have a look, start exploring. You might find a bunch of better ways to write code than you are now. Any questions? So the question is, a lot of packages on NPM are either bundling the types directly, but at least you are installing from @types / the name of that module. And do you think definitely typed is going to go away? So the whole @types namespace in NPM is pushed from definitely typed as an automated process. So if you submit a pull request, they will automatically compile those types and then push them into a package on NPM. There's advantages to definitely typed. So the biggest one is you have a problem with the ecosystem around if the type definitions fall out of sync with the library, once again, you're lying to the compiler. So there's a few things to consider. Ideally, if you put the TypeScript definitions inside, like submit a pull request to that library, that's great. But if the maintainers don't keep that up to date, you have to continually submit pull requests to that library, and that might take a little while for them to merge it. So if you think the library author or that open source project will be reactive and maintain those types, put them in there. But if you put them indefinitely typed, it means you can submit TypeScript pull requests to the TypeScript team. They will review it, publish those changes. So you get normally a lot faster turnaround. So it totally depends. Or if the package is old and you're not going to get a pull request and it published, then yeah, you totally just put it on definitely typed. Mm-hmm. So the question is, if there's bugs in the TypeScript definition and it's in that library and it's in a feature branch but not published yet, can you override it? So TypeScript has a thing called declaration merging. So it really depends on what the issue is. But essentially, declaration merging allows you to define the module types within your code. You could then ignore them and use yours instead, or you can supplement it. So if there's two module, like type definitions that each have like different things, what gets exposed to the compiler is both of those. So it doesn't overwrite, it sort of augments. So you can kind of use declaration merging to get around a lot of that. If the merge changes are incompatible, then you'll have to ignore those type definitions and then provide your own. Yeah, so you can actually, in the TypeScript compiler options, exclude files. So you could try and do that. Anyone else? Cool, thanks everyone.